Hello everyone. In this video, we are going to see the problems on EMF equation of a synchronous generator. In the previous video, we have discussed about the mathematical modeling of a EMF equation of a synchronous generator or alternator. Here we will see how it could be applied on the real-time problems and how can we solve this, right? And So to make remember things, the EMF equation of alternator is 4.44 kp kd, phi is flux, and f is the frequency, p is the turns, okay, and kp and kd are the winding factors. The kd can be calculated by using the formula sine m beta by 2 slash m sine beta by 2. The Kc coil span factor can be determined by calculating cos alpha by 2. And to be considered, Z is equal to 2. All right, and let us consider a problem on EMF equation. A three-phase 16-pole alternator has a star-connected winding with a 144 slots and 10 conductors per slot. The flux per pole is 0.02 Weber, and it is sinusoidally distributed, and the speed is 375 rpm. So find the frequency of the induced EMF, phase EMF, and the line EMF. Also, there is a mentioning, assume the coil as full pitched. So with this problem statement, we could take the parameters. It means the number of poles is equal to 16 and the number of slots is equal to 144 and Z is equal to 10 conductors per slot, and the flux is 0.02 Weber and the speed of the alternator is 375 rpm, and for a full pitch coil the pitch factor is equal to 1. So this need to be considered, pitch factor or the coil span factor. And here we have to find the frequency, the phase EMF, and the line EMF. Okay, and I just here the frequency of the given things can be calculated by using the formula Pn by 120. This Pn, the poles is 16 and the speed of the alternator is 375 and the whole divided by 120. Then we could arrive the frequency is 50 hertz. Okay, and just we are going to calculate certain things which we require to do for distribution factor. And in the distribution factor, we have to determine what is the m value and also the beta value. Okay, so the n can be calculated by using the formula the number of slots per pole. So number of slots here is 144 and the pole is 16, so the n value can be determined by is 9. So which we could take that and we could solve the beta is equal to 180 by n. So here the n is 9, which is determined from the formula where m is equal to n is equal to number of slots per pole. So when we apply here the beta is equal to 180 divided by n, so we will get beta is equal to 20 degree. So now this beta can be taken into consideration, and to calculate the kd there is another parameter called m. So the m can be calculated with the formula m is equal to number of slots per pole per phase. So number of slots here is 144 and the number of pole is 16, and there are three phase alternator which is mentioned in the question. So when we do this we could get a value 3. So these two values and also the beta value can be substituted here in the KD formula, and we could get the value like sine of 3 into 20 by 2 divided by 3 sine 20 by 2, which is equal to sine 30 by 3 sine 30 when we use the scientific calculator, and we can determine the value 0.96. Okay. Then coming back to the Z. So as I mentioned, Z is equal to 10 conductor per slot per phase. So we have to calculate the Z for the 144 slots, and also to be calculated for a phase value. So we are multiplying 10 into 144 divided by 3, which is equal to 480 conductors. And as I mentioned, Z is equal to 2T, T is equal to Z by 2. We have to divide the 480 by 2, which is 240. So we got all the basic values to substitute in the EMF equation. That is E phase is equal to 4.44 kp kd 5 ft. And I'm just substituting 4.44 for kp value. Since it's a full pitch, it's an assumption of 1, and the kd value calculated is 0.96, and the point not to have taken for the flex from the problem statement, and the frequency was determined as 50, and there are total 240 conductors. So when we multiply, and we get 1022.97 volt as a phase value. Okay, since there is a mentioning star connected winding in the question, so this star connected winding can be used with the conversion ratio for the line value. So when I want to get a line EMF, I have to multiply the root 3 with the phase EMF. So root 3 into 1022.97 volt, which is almost equal to 1771.83 volt. So this is how the EMF induced in the alternator can be calculated through the EMF equation from the statement. So this we could take it forward for a few different problems, and we can calculate the EMF equation of a alternator.